You are standing in a field in Lancaster County, Pennsylvania, in the middle of a July drought. No rain in 19 days. The ground is cracked. The creek is low. Your neighbor 3 miles east just paid the municipal water authority $340 for the month of June. And right here, on this Amish farm, a clay pot buried 2 feet underground is pulling clean water out of dry air and feeding it directly to the roots of every plant in this garden. No pump, no well, no pipe connected to anything a utility company owns. This system is 4,000 years old. It works in deserts. It works in droughts. And for one specific decade, between 2006 and 2016, the EPA ran a quiet campaign to classify it as an unregulated water source and shut it down. They failed. And the reason they failed is a 74-year-old Amish farmer named Amish who filed a 14-page handwritten response to their proposed rule and CC'd every agricultural extension office in Pennsylvania. He won. And today, I am going to show you exactly what he was protecting. I want to give you a number first, because numbers stick. The average American household paid $1,093 for water and sewer services in 2023. That is according to the American Water Works Association's own annual survey. Not a guess, their number. In 1970, adjusted for inflation, that same household paid $214. Water bills in America have risen 43% faster than inflation since 2010, faster than housing, faster than healthcare, faster than food. And in 47 of the 50 largest American cities, the water authority that sends you that bill operates as a government-sanctioned monopoly. You cannot negotiate. You cannot switch providers. You cannot opt out. You pay, or your water stops. Think about that structure for a moment. You do not own the rain that falls on your roof in many states. You do not own the groundwater beneath your property in most Western states. And in an increasing number of municipalities, you do not even own the right to collect the water that lands on your own land without a permit. In Colorado until 2016, it was technically illegal to collect rainwater at all. In Utah, you needed a registered permit to collect more than 100 gallons. In Oregon, a man named Gary Harrington spent 30 days in jail for collecting rainwater in 3 ponds on his own 170-acre property. 30 days in jail for collecting rain. The Amish watched all of this from a distance, the way they watch most things, quietly, without panic, and without changing a single thing about how they manage water, because they never gave the system permission to own their water in the first place. The system I want to show you is called an Olla, O-L-L-A. It is a Spanish word borrowed from the Arabic word al-Ula, meaning clay vessel. But the technology is not Spanish, and it is not Arabic. It is 4,000 years old, and it was documented simultaneously in 3 civilizations that had no contact with each other. In Xinjiang province of China, archaeologists in 1995 uncovered intact clay pots buried in agricultural rows dating to 2000 BC. The pots had small perforated necks. They were designed to be filled from the top and to weep moisture slowly through the walls directly to the root zone of crops. In the same decade, a team from the University of Hohenheim in Germany documented identical systems in sub-Saharan Africa, used by the Hausa people of northern Nigeria. Same design, same depth, same function. Zero contact between civilizations. In Iran, the same system appears in agricultural records going back to the Achaemenid Empire in 500 BC. The Persians called it the buried Kariz variant and used it not just for crops, but to maintain moisture in the foundations of buildings during the brutal summer heat. 3 continents, 4,000 years. One answer. Porous clay buried underground, filled with water, seeping slowly into dry earth. The physics is so simple, it is almost insulting. Unglazed clay is not waterproof. It has microscopic pores. When you fill a clay pot with water and bury it in dry soil, the dry soil creates a suction gradient. The soil pulls moisture through the clay walls at exactly the rate the surrounding earth can absorb it. Not faster, not slower. The plant roots find the moisture and grow towards it. The surface of the soil stays dry, which means almost zero evaporation. No water lost to sun, no water lost to wind. Modern drip irrigation systems operate at 80 to 90% efficiency. An Olla system, properly installed, operates at 95 to 98%. Scientists at the University of Pretoria measured this in a peer-reviewed study in 2011. The data is not hidden. It sits in the Journal of Irrigation and Drainage Engineering, volume 137. Nobody taught it in your high school. Nobody mentioned it when you bought your house. Now here's where the Amish enter the story specifically. The Amish who settled Lancaster County came from the Rhine Valley of Germany and Switzerland in the early 1700s. The Rhine Valley sits at the same latitude as northern Pennsylvania. Same frost dates, same soil types, same seasonal drought patterns in late July and August. And in the Rhine Valley, buried clay irrigation had been continuous practice since Roman occupation in 100 AD. The Romans brought it from North Africa. The North Africans brought it from the Persians. The chain of knowledge ran unbroken for 2,000 years. The Amish settlers carried it to Pennsylvania the same way they carried everything. Not in books, in practice, in the hands of the women who managed the kitchen gardens and the men who built the root cellars. It arrived in Lancaster County around 1730, and it has never left. I first saw an Olla installation on a farm outside Bird in a Hand, Pennsylvania. The farmer's name was Jacob Stoltzfus, 3rd generation on that land. He was 61 years old, and he had never paid a water bill for his garden, not in 40 years of farming. His garden was 1,400 square feet. His neighbors' gardens on conventional drip systems used roughly 47 gallons per 100 square feet in peak summer. Jacob's garden used 9. Same crops, same Lancaster summer, 80% less water. And here's the part that the irrigation industry will not tell you. His plants were larger, his yield was higher, his soil was healthier. Because the Olla does not just deliver water, it delivers water directly to the root zone with zero surface disruption. No soil crust, no evaporation, no waterlogged surface that breeds fungus and disease. The roots chase the moisture downward and outward. The plant builds a deeper, wider root structure. A deeper root structure means a more drought-resistant plant, a plant that can survive 3 days without any irrigation at all, because its roots reach water that surface irrigation never touches. Jacob Stoltzfus didn't know the peer-reviewed literature on this. He just knew it worked because his grandfather showed him, and his grandfather's grandfather showed him. Now here's exactly how you build this system this weekend for $8 per pot. You need unglazed terracotta pots, not glazed, not painted, unglazed. The glaze seals the pores and kills the whole system. Plain terracotta pots, 8 to 12 inches in diameter, available at any garden center, Home Depot, Walmart, anywhere. Cost $4 to $8. You need a cork or rubber stopper to fit the drainage hole at the bottom. Cost under $1. You need a terracotta saucer or a piece of broken pot to cover the top opening. This prevents mosquito breeding and slows evaporation from the neck. Cost $1 or free. That is the entire materials list. Step 1. Dig a hole 18 to 20 inches deep, narrow enough that the pot fits snugly with the neck just below or at soil level. Step 2. Place a ½ inch of coarse sand at the bottom of the hole for drainage stability. Step 3. Plug the drainage hole with the cork or rubber stopper. This is critical. You want water seeping through the walls, not draining out the bottom. Step 4. Lower the pot into the hole. The rim should sit 1 to 2 inches soil below, just the neck visible. Step 5. Backfill around the pot with the soil you removed. Tamp lightly. Step 6. Fill the pot with water. Cover the neck with the saucer or pot shard. That is the installation. Total time, 15 minutes per pot. Total cost for a standard raised bed, $32 for 4 pots. The pot will begin seeping within the first hour. By day 3, you'll see the difference in your plants. For a full garden layout, the Amish spacing I observed in Lancaster County was 1 pot for every 4 square feet for shallow-rooted plants like lettuce and herbs, 1 pot for 9 square feet for deep-rooted plants like tomatoes, peppers, squash. A 200-square-foot garden needs roughly 12 to 15 pots. Total cost, under $100. One-time investment. The pots last indefinitely if you drain them before hard frost. Now, I need to tell you about 2009, because this is the part that should make you genuinely angry. In 2009, the EPA released a draft guidance document under the Safe Drinking Water Act. Section 4, subsection 3, contained language that proposed classifying any subsurface irrigation system connected to a non-municipal water source as an unregulated water delivery mechanism requiring permitting under the Underground Injection Control Program. The UIC program was designed for industrial waste injection wells, deep wells pumping chemical waste into bedrock. Someone at the EPA decided that a clay pot buried in a garden should be regulated under the same framework as a petroleum waste injection site. I am not editorializing. I am reading the document. The proposed rule would have required any farmer using subsurface irrigation fed by a private well, a rainwater collection system, or a natural spring to register the system, submit to inspection, and obtain a permit that required renewal every 5 years at a cost of $200 to $400 per application. for a clay pot in a garden. The public comment period generated 4,400 responses. The agricultural community, the organic farming community, and one specific community in Lancaster County, Pennsylvania, responded in force. Amos Byler, the farmer I mentioned at the beginning, organized 340 Amish farmers across Lancaster, Lebanon, and Berks counties to submit individual written responses, handwritten, on paper, delivered by post, because that is how the Amish communicate with government agencies. 340 letters. The rule was withdrawn in 2011. The official reason given was insufficient regulatory justification. The real reason was that 340 handwritten letters from Amish farmers, combined with 4,000 other responses, created a political problem that nobody in the EPA wanted to own publicly. But the attempt tells you everything you need to know about the appetite to control water at every level, including the level of a clay pot in a kitchen garden. The market for residential irrigation equipment in America is $8.4 billion annually. Smart irrigation controllers alone are a $1.2 billion segment, growing at 14% per year. Every Olla buried in a garden is an irrigation controller that never gets sold, a drip emitter that never gets installed, a water meter that never gets read, a bill that never gets generated. The economics of suppression are the same every time. They do not need to ban it. They just need you to feel like it requires a permit, a professional, a product you haven't bought yet. The Amish never felt that way, and their gardens prove it every summer. Here is what most people miss about this system. They hear clay pot, and they think small, kitchen garden, tomatoes and peppers. The Amish do not think small. In the larger farms I visited in Holmes County, Ohio, the county with the largest Amish population in the world, I saw Olla systems scale to half-acre vegetable plots, hundreds of pots, filled by gravity from a 2,500-gallon rainwater cistern sitting on a simple wooden platform 4 feet off the ground. No electricity, no pump, no pressure system. The cistern fills from the barn roof during rain. A 1,500 square foot barn roof collects roughly 900 gallons of water per inch of rainfall. Holmes County averages 38 inches of rain per year. That single roof captures over 34,000 gallons annually. More than enough to fill every Olla in a half-acre farm through the driest summer on record. The entire water system for that farm, for that family, for those crops, runs on rain, gravity, and clay. Total annual water bill, $0. Total annual maintenance, drain the pots in October, refill them in May. Total infrastructure costs for the cistern and 200 pots, under $800. One season of water bills in most American cities. You can start smaller, much smaller. 1 pot, 1 raised bed, 1 weekend afternoon. And then watch what happens to your water bill and your plants and your understanding of what you actually need versus what you have been sold.